Welcome to Penrose Learning, where we make understanding easy.
You start by listing every force on the object and picking axes. Do that now. Place one axis along dominant motion to simplify math. Place the other perpendicular. Next, resolve any angled force into components using cosine for the adjacent and sine for the opposite. Write each component as a signed value so direction is explicit. Once done, label magnitudes in newtons and note angles. This foundation makes summing vectors straightforward and avoids signs. Now compute numeric components for every force you listed. Be careful with signs. Left and down are negative if your axes are right and up. Add all x components to get fx total, then add all y components to get fy total. Make sure units are newtons and keep 2 significant digits to limit rounding error. Once you have both totals, you have a vector in component form. Make sure to double-check trigonometric values if any angles were approximated. Finally, compute the net force magnitude with the square root of the sum of squares and find direction using arctan 2 to preserve the correct quadrant. Express the angle relative to your chosen axis and include the n unit. Once done, cross-check the result against the free body diagram to catch sign mistakes or a missed force. If the magnitude seems wrong, re-evaluate component signs and any small forces you may have neglected. Often a single sign error causes the biggest discrepancy.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.